And that brings us to the layered approach of indoor air quality. So here's some ways to keep the air clean. The number one thing should be source control. Don't bring stuff into your house that's going to off-gas like crazy, or don't do stuff in your house that's going to create problems with the indoor air quality. If you want to have really good indoor air quality, you got to pay attention to all this stuff. So look for good materials that aren't going to put formaldehyde in your air and things like that. Air tightness. Air tightness keeps the stuff from the outside from getting in through the building enclosure. It would have to come in through the ventilation system where it can be filtered if it's a particle. Filtration, and we'll talk in a little detail about all these things in a minute. Ventilation. So filtration is for particles, ventilation is for gases. So with filtration, we are removing the pollutants. With ventilation, we are diluting the pollutants. So some people say dilution is the solution to pollution, right? You've all heard that probably. Well, dilution is part of the solution because we want to follow a layered approach here and do all these things because all of them could, if we lack any of these, that could create some problems. If we do everything but air tightness, we're leaving pathways for outdoor pollutants to get through into the house. Moisture control, we talked about that a little bit, and I've got more to say about it. And then pressure balancing. Pressure balancing. Anybody know what that's all about? Air exchangers. Well, that would be maybe ventilation or air tightness when we talk about air exchanges. Difference in pressure between outside and inside. Well, if we have a good air barrier, that's not so important. Pressure balancing, what I'm referring to here, you're on the right track. What I'm referring to here is if you have a bedroom, let's say you're heating and cooling with a forced air system, not hydronic, and you have bedrooms that have supply air being dumped in them, but there's no return, and there's no return air pathway. So the system is running, you're putting, let's say, 100 cubic feet per minute of air into the bedroom. You close the bedroom door, what happens? You're going to get a positive pressure in the bedroom, which means you're going to get a negative pressure where the return is, the central return. And so that can do a number of things for your indoor air quality. Number one, the negative pressure could be high enough that it backdrafts a water heater. If you've got a natural draft water heater, you could build up enough negative pressure in the house just by closing bedroom doors to backdraft the water heater, which could put carbon monoxide in the house and other exhaust gases from the water heater. Another thing that can happen is by creating these pressure differences in the house, when you close the bedroom doors, you're causing exfiltration from the bedrooms because you got positive pressure, so it's looking for ways to get out. And where the negative pressure is, you're creating the possibility of infiltration. So that can bring bad air from the garage, from the basement, from the attic. So that negative pressure, we don't want that negative pressure in the house because that can bring the bad stuff in from places where we don't want it coming from. So pressure balancing is another important step in the layered approach to indoor air quality. So this was a couple years ago at the Westford Symposium on Building Science, also known as Building Science Summer Camp. We did a bunch of things. So this was right after the pandemic was coming to an end. And so we had 400 people there in this big room. So ahead of time, a bunch of people got together and they got with the facilities people at the hotel and they changed out the MERV 8 filters and the air handlers with MERV 13. MERV 13 is better for filtering out the small particles. And we also put MERV 13 filtration in the room. We had, I think, 4 of these Corsi Rosenthal boxes. Anybody know what a Corsi Rosenthal box is? How many of you do not know, have not heard of the Corsi Rosenthal box? Wow, okay. Ooh, do I have a picture of that? I think I have a picture. Not right here, though. If I don't have a picture, I'll bring one up later. The Corsi Rosenthal box is very simple, and there's a lot of these people made during the pandemic. It's just a box fan, a 20-inch box fan, and 4 MERV 13 filters taped together in a box with a piece of cardboard on the bottom. Or you could put another filter on the bottom and have 5 filters and have it up on blocks or something, suspend it. The idea is that you get portable filtration. You can build these things for less than $100. Well, maybe more than $100 Canadian, and maybe more than $100 now because things have increased in price. So this is a great way to get filtration in places where you need it. Come on. All right, ventilation. Another thing they did is that with the facilities guy at the hotel, they went up on the roof when they were changing the air handlers. They looked at the ventilation situation, and the dampers were closed. A lot of times, I think facilities do this because it costs more to add ventilation air because it requires more heating, more cooling, more dehumidification when you do that. So they opened the ventilation dampers, and we had outdoor air diluting the indoor pollutants. And we had these things. So I think we had about 4 of these in the room. This is upper room UVGI, ultraviolet germicidal irradiation. So UV does work. It can deactivate viruses and kill bacteria. It can also hurt people. So you've got certain wavelengths of it are not good for people. So that's why this is aimed at the upper room. So this was a room with probably 15 to 20 foot ceilings. So they're zapping the air in the upper part of the room. The air handlers are mixing it so that the zapped air gets mixed in so we get cleaner air. Any viruses and bacteria get cleaned. And this was right after the pandemic. Is that the last one? We had like 400 people there. Nobody got COVID from being in that room. One person got COVID, but he said it was from a meeting they had in another room that didn't have these kind of protections. And that was pretty good because in 2022, there were a lot of conferences that people went to, and a bunch of people came back with COVID. This conference did not have that issue. Also, mask wearing was a pretty low percentage there. So, with indoor air quality, there's not a silver bullet. It's not build tight, ventilate right. That's important, but that's only 2 of the steps. So there's silver BBs. We got to do a bunch of these different things. Source control, moisture control, pressure balancing, filtration, ventilation, air tightness. All these things matter. And let's go into a little bit more detail on some of these. So carpet, I mentioned, is a really bad one. This is, the carpet pad and then the carpet. How many of you have ever smelled new carpet before? Nobody says they love that new carpet smell. Everybody loves the new car smell, but nobody loves the new carpet smell. You love the new carpet smell? Yeah, so it depends on the carpet. There are good carpets and bad carpets, and it depends on the materials that go into them. But when you go to a regular carpet store and buy the standard carpets, it's going to be smelly a lot of times. Yeah, these things have a lot of VOCs that come off of them when they're new. And yes, you can smell them for probably 2 weeks when they're new, and it's really strong. I mean, and they don't stop at 2 weeks though. They're still off-gassing and putting VOCs into the air, but the rate goes down quickly. Yeah.
The flip side of old carpet.
Old carpet.
Skin dander, spills, water.
Yeah. So old carpet can definitely create indoor air quality problems as well, especially for toddlers who are crawling on the carpet and licking the carpet. Yeah, because there can be a lot of stuff in there. So, if you're, for people who are chemically sensitive, really sensitive to stuff in the air, they usually don't have carpet because of those kind of issues, because carpet can hold a lot of stuff in it. All right, here's a one I mentioned earlier, gas logs. This was at a house that I did quality assurance on a while back, and you know, when I see this, I always look up, and so this is what the top of the box looked like. Notice there is no hole there. This is a room vented gas log fireplace. Some people might call it a lung vented gas log fireplace because everything that comes off of that is getting into the room. Now, any chemists in the room here? Combustion scientists? So when you burn natural gas, methane, CH4, you're combining it with oxygen, and you get from that, if you have complete combustion, you get two products only. You get water vapor and you get carbon dioxide. So water vapor is not harmful to our health directly. Carbon dioxide, we're breathing it right now, probably 6, 8, oh, hang on, I can tell you how much we're breathing right now. I brought my monitor. Right now, my monitor says we got 1,568 parts per million of carbon dioxide in this room. So when you put a bunch of people in a small room, carbon dioxide levels go up because we're all exhaling carbon dioxide. Combustion, the perfect combustion of methane gives you carbon dioxide and water vapor. Neither of those things is directly harmful at the levels we normally breathe them, but you know, water vapor can grow mold. Carbon dioxide indicates a lack of sufficient ventilation, because if we have a good ventilation system, we should be diluting the amount of carbon dioxide and other pollutants in the air. So a carbon dioxide level, a carbon dioxide monitor is a good way to see how good the ventilation system is. That's all. It's not telling you, oh, it's over 1,000 parts per million, I'm going to get sick, I'm feeling dizzy. It's usually not that. There's a lot of studies on this which are kind of all over the place. Yeah?
Question about indoor combustion. A modern airtight wood-burning fireplace that has combustion air brought in from outside, is that like reasonable in a house, or is that still pretty risky?
Yeah, so an airtight fireplace, like, you know, wood-burning stove with its own combustion air brought in. So by bringing the combustion air in, you're not going to change the pressures in the house, which is good. And if it's airtight, all the pollutants generated by the combustion are going up the flue, which is good. The issue with even the really good wood stoves is that when you open them to put more wood in, or when you're first starting the fire, you get a burst of particulates in the room, and it lasts for a little bit. So you know, usually not that big a deal.
Because I always was under the impression that when you open the door, it's sucking air in and going, like, because there's a draft in the chimney, should it not be
Well,
sucking air out of the house?
if you monitor the indoor air quality with a particle monitor, you'll see a spike in the particulates when you open the door and do stuff. So yeah, I mean, yeah, you're right. I mean, you know, the pressure should cause the air to go in, but still, you get some of it does get out. So good question. So yeah, I mean, having an unvented gas fireplace is a bad idea. So ways to minimize the effect of pollutants is we can have VOC barriers. So spray foam in a wall cavity, for example, is going to have drywall over it. Spray foam can off-gas. Drywall can keep that off-gassing from getting into the house. Material conditioning. So you'll leave it outside the house for a while before you bring it in. Put it in the garage, then bring it in after it's off-gassed. You can, if you get a whole bunch of stuff coming in at once during construction or renovation or something, you can bring it in a little at a time. And you can delay occupancy. You know, when a house is just finished, you let it sit for a while, and you can also combine that with a building flush out. Now, when it's minus 20, you might not want to flush it very much, even if nobody's there. And then once it's occupied, you can set the ventilation system to run at a higher rate early on, and then as the house gets conditioned, and when the off-gassing goes down, then you can ramp the ventilation rates down. So air tightness, a really big one. The air barrier is one of the first things that should go into the design of a new house, thinking about how are we going to do the air barrier? How are we going to get it sealed? There's a lot of ways to do it. This is zip sheathing, taped zip sheathing with the membrane on the outside and the tape on the seams. And this is, in Atlanta, there's a retired EPA guy named Danny, I mentioned in the book, and I've got a graph of his energy bills coming up in a little bit. Over time, he has dropped his energy bills way down by doing, over the last 30 years, he's done a lot of work on the house. This is one of the things he did. He had all the insulation removed from the attic, went in there and sealed up all the top plates, all the penetration, so he's got an airtight lid over the house, and then he put insulation back in there. This is a project I visited in Philadelphia a few years ago. These are Build Smart panels. It's like a structural insulated panel on the outside, so you see the white expanded polystyrene foam there with the zip sheathing on the outside. You can't tell the zip from here, but there's zip sheathing on the outside. And the air barrier is in the middle, and then there's a frame section on the top. So the air barrier is in the middle where it's most protected, which is good, because if you're, 40 years ago, there was this big thing about the airtight drywall approach. And there was a lot of it happening in Canada. The problem with airtight drywall is, how long is it going to stay airtight? Because people get in the house and they cut holes in the house. They punch holes for hanging pictures and stuff. And then something happens with the plumbing behind the washing machine, so they pull the washer out and cut the wall open and then just push the washer back when it's done and say, well, I guess somebody come patch that drywall later, but they've got a big hole. So airtightness, really important to keep the outdoor and buffer space problems in. So you got to know how to do it right. This is a great picture of the opposite. This is an example of what happens when somebody knows what to do, but they don't know why they're doing it. Somebody was handed a can of spray foam and said, here, go spray the edges of that wall over there, that little knee wall. So they sprayed around the pink fiberglass and wasted a can of foam, or however much they used. So airtightness is really good, but build tight, ventilate right is just build tight is not the whole solution to indoor air quality, because by building tight, yes, we can keep the outdoor pollutants and the buffer space pollutants from getting into the house, but we still do things in the house, and we have things in the house that create pollutants that can cause health problems. So those things, we've talked about some of those already. Radon, VOCs, and carbon dioxide. These things get in the house. Carbon dioxide, I mentioned, is not a pollutant per se. You would have to get up to like maybe above 5,000 parts per million of carbon dioxide to cause serious health problems, I think. There are people who live in submarines and on spaceships who are breathing high levels of carbon dioxide. So NASA and the Navy have had a big interest in carbon dioxide levels and their effect on health. And so they've done a bunch of research on that area.